Hello everyone, how are you all? I welcome back. Today we are going to start our journey into classification algorithms. One of the most important areas in machine learning. By the end of this video, you shall not only understand what is classification is, but you shall also be able to implement your first algorithm, that is k nearest neighbor. Okay. So let me go to the second slide. So first is like classification. Okay. So classification means assigning input and predefined labels. Okay. So for example, for emails, there are spam or not spam. For like patient, like healthy or sick, or for customer, you can be churn or retain. Okay. So the type of classification is we are using, which is binary, which is two classes, true or false. Or the second one is multi-classes, in which there is more than two classes are there, and multi-label means multiple tag at once. Okay, so let's go to the notepad for the better understanding for this topic in detail. So let me open the notepad now. Okay, so now just we will understand like introduction to classification. Okay, so let me write it down. Introduction to classification. Okay, so basically, a supervised learning. So this is nothing but a supervised learning uh, task where the target, or you can say the output variable is categorical, or you can say discrete value, okay. So this is about the definition part, what it is, just for your notes. So with an example we will understand it. So suppose one example is given like email classification, okay. So in the email classification, we have to search like spam or not spam. So we are basically classifying it. So in the sentiment analysis, the first one is email classification, and the next one is your sentiment analysis. So in this, basically what happens? So there is one positive or negative or neutral. Okay, and the disease prediction. In the disease prediction, you can say like yes or no. Okay, or no. So this is how you can classify. So this is comes under the classification. So there are different type of classification techniques are there. So we'll understand one by one. So the first one is your types of classification. Types of classification. So in the type, the first one is your binary classification. Binary classification. So what is binary classification basically? So in this there are two categories. Two categories. For example, suppose example, suppose male or female, or you can say spam or not spam, spam oblique not spam. Okay, so this is comes under the binary classification. So the next one is like multi-class classification. Second one is your multi-class multi-class classification. So what is multi-class classification? Means more than two classes are there. So more than two classes are there. Okay, for example, you are predicting some fruit name. Okay, for example, predicting fruit. So there are like multiple fruits, which you can say like apple, banana, or mango. So in this, there are more than one class. Inside the fruit, there are so many classes like apple or your banana or your mango. So like that. So this is comes under the multi-class classification. So the next one, or you can say is your third one, which is multi-label, multi-label classification. Okay. So in the multi-label classification, like each instance can belong can belong to multiple classes. For example, uh, suppose U2. Okay. So predicting tag for a YouTube, like video, it can be music or your sports or your travel, etc. Okay, so this comes under the multi-class. So let's take it, just analyze all in the simple way. Like there is one input, okay, input feature, and your classifiers. There is some classifier, and after the classifier, we are predicting the classes. Okay, so predicted classes. Okay, so this is the block diagram how it works. Okay, so in the classifier we have already learned about the binary, multi-class, and multi-label. Okay, so this is about the introduction to the classifier. So let's move to the workflow of a classification problem. Okay, so workflow of classification, a workflow of classification problem. Okay, so the first is your data collection. Data collection. So in the data collection, you are collecting your data by your audience or your previous source or anything. From any resource, you are like collecting the data. Okay. And the next one, which is your data pre-processing. So data pre-processing. So in data pre-processing, we are doing like cleaning, scaling, and encoding. Okay, so the third step the in the workflow of the classification problem is your splitting into training and testing. Okay, so splitting into training and testing, training and testing. Okay, so the fourth one is your model training. Okay, model training, which is your fit classifier. So the fifth one is your model prediction. Okay, so till now we have like given the data collecting the we have already collect the data and we have clean it. So the next one is like we have split into the training part and testing part, and then we have trained the model. So now it's time to predict the model. Okay, so model will predict the outcomes. So prediction, model prediction, and the last step, which is very important, which is your model evaluation. Model evaluation. So in this, we are understanding the accuracy, precision, and recall. Okay, so in the further lecture, I think I am going to cover these all things, accuracy and precision and recall. Okay, so this is about the workflow of the classification problem. Let me zoom it out and just write it down. This all steps is very important. Okay, so I hope you have written. So now we will move further. Uh, okay, so the next one is your k nearest neighbor, which is KNN. So the concept is the k nearest neighbor is like lazy learner, and in this there is like majority of voting. Okay, so in this we are learn about the distance matrix. So there are so many like Euclidean, Manhattan, and cosine similarity. Okay, and then we will choosing the k value, like small k means sensitive to noise and large k means smoother or risk over the generalization. Okay, and then there are some prompts and cons in this. So the prompts is like it is simple and no training needed, but the cons is like it is slow with the large data and sensitive to irrelevant features. Okay, so let me raise this up and we'll go to the notepad for its better visualization and understanding of KNN. So, so basically, the KNN is KNN, K nearest neighbor. Okay, so in this, uh, so in this, the concept and the institution is like your, you can say the KNN is lazy learner, lazy learner or no training phase. There is no training phase, no training phase, and there is only memorize the dataset. In this only we are memorize the dataset which is given, the data set. Okay, so when a new data points come in the KNN, so KNN looks at the k closest point, which is the neighbors in the training data set. Okay, so the prediction is like the majority votes. So in this how the prediction happens. So prediction happens on the majority of vote. So for the classification, okay, so let's understand it with one example. So suppose we want to predict whether a student will pass or fail based on the study hours and attendance. Okay, So we will plot existing student on the 2D graph. Okay, so for a new student, look at the nearest neighbors. So if most nearest neighbor are like pass, so predict the pass. Otherwise, we will predict the fail. So this is about the k nearest neighbor. Now steps in the k nearest neighbor algorithm, which is like, let me go to the next page only. So steps in KNN algorithm. So the first step is like choose the number of the neighbor. Okay. So the first step, choose the number of neighbors. So what it means, we are finding the k value first. Okay. So the next is like calculate the distance. Calculate the distance between between the new points and all training points. All training points. Okay. So the common distance formula, which is like Euclidean distance. So in this common distance is your like Euclidean distance, which we are using Euclidean distance. Okay, so Euclidean distance formula, I hope you guys know. So x minus y1 ka square, x1 minus y1 ka square plus x2 minus y2 ka square. Okay, so after that, the fourth step, or you can say the third step, which is assign the majority class majority class among these neighbors. Okay, so the first step, what we are doing, like we are choosing the k value first, and then we are calculating the distance between the new point to the all training points. So the formula which we are using is your Euclidean distance, which is nothing but root under like x minus x1 ka square plus y minus y2 ka square. After that, we are assigning the majority class among these neighbors. Okay, so this is how the steps involved in the k nearest algorithm. Okay, so uh, the here we have seen like the first we are choosing the k value. Okay, so let's understand like choosing the k value, like how we are choosing it. Okay, so the topic is choosing choosing the value of k. So how we are doing, like, okay, so small k is k is equal to 1. So more noise will be there, more noise, or you can say overfitting. Okay, and if there is large k value, example like k is equal to 20, if you have taken, so it is smoother boundary, but it may lead to the underfitting. Okay, so rule of thumb, there is one more rule, which is like rule of thumb. So in this, basically what happens, so k which we are taking is really like almost equal to the root of n. Okay, where n is equal to number of samples. We are taking its square root and we are finding the k value. So this is how we are avoiding the overfitting and underfitting while selecting the k value. Okay. So let's discuss some advantage and disadvantage of KNN. So let me write it down. Advantage and disadvantage of KNN. So the first one is like advantage. So if you talk about the advantage, so it is simple and intuitive. Okay. And the second is like your no training time. So no training time. So in this we are just basically storing the data. Okay. So just store data. Okay. So the next one is like works for your both classification and regression. Classification and regression. Okay, so these are some advantage. So there are some disadvantage also. So disadvantage. So the disadvantage is like your first one, computationally expensive for large data set. Okay, so computationally, it is expensive for large data set. Okay, so it needs to distance calculation with all the points. That's why it is like expensive little bit. And the next one is your sensitive to irrelevant features, irrelevant features and scaling. So for example, height in the centimeter and weight in the kg. So this is like the sensitive irrelevant feature for the scaling. Okay. And the next one is like struggles struggles with high dimensionality or high dimension data. Okay, so it curves of dimensionality. So I hope I am clear with the KNN and its advantage and disadvantage. So what do you guys think? Should I show you the practical implementation of KNN? Uh, okay. Let's see the practical demonstration of KNN. Okay. So for that, I have to open the Jupyter notebook. So just hold a second. I'm opening the Jupyter notebook. Just a second, guys. It's opening. Okay, yeah. So it's open. So let me minimize the all the tabs. Yeah. So here, I think we have to create one file. So I'm going to create one notebook first. Okay, notebook is important because no data set is required. We will take the iris data set only. Okay. So select it and just name it like KNN. Okay. So for that we have to import some libraries. Okay. So first we will import the NumPy and then pandas. Okay. So first wait a second. So first we will import like NumPy. So for that we will write like oh import NumPy as NP. Okay, and then we will import the pandas. So for that, import pandas as PD. and then we will import the train test split from the sklearn model selection. Okay, so from sklearn dot model selection, okay, we are importing like import train test split. Okay, so next we'll import the k nearest classifiers or your k nearest or your k neighbors classifier from the sklearn neighbors. Okay, so from sklearn sklearn dot neighbors, we will import the your k neighbors classifier. So k neighbors classifier. So the next we will do like we will import the accuracy score from the matrix. So from sklearn dot matrix sklearn dot matrix import what accuracy score. Okay, so just run this. So just press shift and enter. So just a second, it's running now. Yeah, so we have imported the library. So next, we will like, for example, we will take the iris data set. So for that, we have to import the iris data. So from sklearn dot dataset, I import your load iris. Okay, load iris. Okay, and then you are going to importing it. So iris is equal to load iris, load iris, and then you are like classification it. You are classifying it. So x is equal to iris dot data, iris dot data, and y is equal to iris dot target. Okay, so just run this. So for example, we have imported the data set. So now we will split it down. Okay. So for that we will write like x underscore train, comma, x underscore test, x underscore test, comma, y underscore train, comma, y underscore test is equal to train test split, and then in the bracket we will write like x, comma, y, comma, test size, which we will give like 0.2 or 0.2. Okay, and the random state we will give like 42. So random state is equal to 42. Okay, so just run this. Oh, there is one error, x is not defined. So here I will write like capital X. Okay, so okay, so we have splitted the data. So now we will initialize the KNN with like k is equal to 5 value. Okay, so how we will do that? So KNN is equal to k neighbors classifier, and then we will write like n underscore neighbors is equal to value is equal to 5. Okay, so now we will fit it to KNN dot fit, and then we will write like x underscore train, and on the training data we will split it, sorry, we will fit it, so y underscore train. Okay, so now we have initialized the KNN with the 5. So now we'll do the prediction. Okay. So for the prediction, we will write like y underscore predict is equal to KNN dot predict. Okay, and what we are going to predict x test. Okay, so x underscore test. Okay, so now it is ready to predict. So just we will print the accuracy score. So print your accuracy and comma from the accuracy score. Okay, and for what you are going to predict, print the accuracy. So y test and y predict. So y underscore test, comma y underscore predict. Okay, so just run this. Uh, okay, so just run this. So here we have got the accuracy is equal to 1. Okay, so this is how we can initialize, so this is how we can like import the library, and from that we can take an example just like for your iris dataset, and then what we have did, so we have did the splitting of the dataset, like the test size means 0.2 means the testing is zero point 0.2 means your 20% and training data is 80%. So generally we are dividing it into 20-80 ratio. So after that we have initialized the KN with the K value is 5, and then we have predict the model, and then we have predicted the accuracy part. Okay, so this is how the KNN works. So this is the practical demonstration for this one. So now uh, in this session, I'm going to wind up. So, in this session, we have learned about the basics of classification and the workflow, and then we have deep dive into the k nearest neighbor algorithm. So, you saw how a simple yet powerful it can be, and especially for the smaller dataset, it is very efficient. So, in the next lecture or in the next video, we will explore the decision tree and random forest. So, which are the more advanced of the powerful classifier or powerful classification model. So, तब तक के लिए keep learning and keep exploring. See you in the next video. तब तक के लिए, bye bye.